Have you ever wondered what it would be like to be in two places at once? In the quantum world, this isn't just a thought experiment, it's reality. Welcome to the fascinating, mind-boggling realm of quantum superposition, a cornerstone of quantum mechanics that defies our classical understanding of reality. In our everyday classical world, objects exist in definite states. An apple is either red or green, a door is either open or closed. But in the quantum realm, things are not so straightforward. Quantum particles, like electrons or photons, can exist in multiple states simultaneously. This is the concept of quantum superposition. To put it simply, a quantum particle can be in two places at the same time, or possess multiple properties at once. It's as if you could be both at home and at work simultaneously, or a light bulb could be both on and off at the same time. Sounds impossible, right? But in the quantum world, this is the norm. A perfect illustration of this concept is the famous thought experiment known as Schrödinger's cat. Imagine a cat inside a sealed box with a radioactive atom that has a 50-50 chance of decaying and killing the cat. According to quantum mechanics, the cat is both alive and dead until someone opens the box and observes the cat. In other words, until the cat's state is observed, it remains in a superposition of being both alive and dead. This might sound strange, perplexing even, and it's meant to be. Quantum superposition challenges our intuition. It defies our everyday experience of the world around us. But it's these very counterintuitive properties that make the quantum world so fascinating and full of potential. So let's dive deeper into this quantum enigma. In the quantum realm, the cat is both alive and dead, until someone opens the box and observes the cat. Imagine a computer that can perform calculations billions of times faster than any device currently available. That's the power of quantum computing. Quantum computing is a revolutionary field that takes advantage of the strange and counterintuitive principles of quantum mechanics. One of these principles is superposition, a concept that defies our classical understanding of the world. Superposition allows quantum particles like electrons or photons to exist in multiple states at once. This is a stark contrast to the world as we know it, where things are either one way or another, but never both at the same time. Now you might be wondering, how does superposition play into quantum computing? Well, it has everything to do with something called a qubit, or quantum bit. In classical computing, information is stored in bits. Each bit can be either a 0 or a 1. It's a binary system, an either-or situation. However, in the quantum world, things aren't so black and white. Thanks to superposition, a quantum bit or qubit can be in a state of both 0 and 1 simultaneously. This both and state of qubits is what gives quantum computers their incredible processing power. It means that a quantum computer can process a vast number of possibilities all at once. For certain types of calculations, this allows a quantum computer to find a solution exponentially faster than a classical computer ever could. But it's not just about speed. The ability for qubits to exist in multiple states at the same time also means that quantum computers can handle much more complex calculations. They can solve problems that are currently beyond the reach of even the most powerful supercomputers. So, in essence, superposition is the secret sauce that makes quantum computing so powerful. It's the reason why quantum computers can perform calculations of a complexity and speed that are currently unimaginable with classical computers. With superposition, a qubit can be both 0 and 1 at the same time, unlocking unprecedented computational power. Ever heard of a single particle interfering with itself? Welcome to the strange world of quantum interference. Interference in quantum mechanics is a phenomenon that occurs when the probability amplitudes of different states combine. This can happen either constructively, where the amplitudes add together to increase the likelihood of a particular state, or destructively, where the amplitudes cancel each other out, reducing the probability of a state. Now let's bring this abstract concept to life with the famous double-slit experiment. Picture this. We have a barrier with two slits and a screen behind it. We fire a stream of particles, say electrons, at the barrier. In the classical world, we'd expect each electron to pass through one slit or the other, creating two bands on the screen behind. But that's not what happens. Instead, we observe an interference pattern, as though the electrons were waves that passed through both slits simultaneously, interfering with themselves. This creates a series of alternating bright and dark bands on the screen, a clear sign of wave behavior. This is wave-particle duality in action, where particles like electrons exhibit both particle and wave characteristics. But here's where it gets even weirder. Even when we fire electrons one at a time, we still get an interference pattern over time. This implies that each electron, as a quantum particle, goes through both slits and interferes with itself. However, if we try to observe which slit the electron goes through, the interference pattern disappears, replaced by two bands as we'd expect from particles. This is a direct result of measurement or observation affecting the state of quantum particles, a phenomenon known as wave function collapse. In the quantum world, the mere act of observing can change the outcome, a concept that defies our classical intuition. It's as if the particles know they are being watched. This is beautifully demonstrated by the double-slit experiment, a testament to the counterintuitive and fascinating nature of quantum mechanics. In the quantum world, observing the path of a particle can change the outcome, a phenomenon beautifully demonstrated by the double-slit experiment. Quantum superposition is not just a scientific fact, it's a philosophical conundrum that continues to challenge our understanding of reality. Diving into the depths of quantum mechanics, we find ourselves amidst a whirlpool of interpretations that seek to demystify the nature of superposition. For instance, the Copenhagen interpretation, one of the earliest and most widely accepted explanations, suggests that a quantum system remains in superposition until it's measured or observed. It's like flipping a coin in the air. It's both heads and tails until you catch it and look. However, this interpretation raises more questions than it answers. If an observation causes the collapse of superposition, then what qualifies as an observer? Does it need to be a conscious being, or can an inanimate object serve the purpose? On the other hand, the many worlds interpretation takes a different approach. It proposes that all possible outcomes of a quantum event actually occur, but in separate parallel universes. So, when Schrödinger's cat is both alive and dead in superposition, the universe splits into two, one where the cat lives and another where it doesn't. Yet these interpretations are not without their critics. The Copenhagen interpretation, for one, is often seen as incomplete or even unscientific due to its reliance on the vague concept of measurement. The many worlds theory, while mathematically consistent, is criticized for its extravagance. After all, the idea of an infinite number of parallel universes popping into existence with every quantum event is a lot to swallow. This ongoing debate reflects the complexity and paradoxical nature of quantum mechanics. Each interpretation offers a unique lens through which we can view and understand superposition, yet none provide a definitive answer. It's like trying to describe an elephant by touching different parts of it. You get a sense of the whole, but the full picture remains elusive. From the Copenhagen interpretation to the many worlds theory, quantum superposition continues to perplex and fascinate scientists and philosophers alike. What if we could harness the power of superposition? What might the future look like? Imagine a world where data transfer is not only faster, but also unbreachable. A world where our computers work at lightning speed, solving complex problems in the blink of an eye. This is the future that quantum superposition could help us unlock. In the realm of technology, quantum superposition is a game changer. It's like giving our gadgets a quantum upgrade, enabling them to operate on a whole new level. The most noteworthy application lies in quantum computing. While classical computers use bits as their smallest unit of data, quantum computers use quantum bits or qubits. Unlike bits, which can only be a 0 or a 1, qubits can be both at the same time, thanks to superposition. This means quantum computers could perform calculations much faster than their classical counterparts. But the potential of superposition extends beyond just computing. It also holds immense promise for quantum communication and quantum cryptography. In the realm of quantum communication, superposition could enable the transfer of information at unprecedented speeds. With quantum cryptography, superposition could provide a way to create unbreakable codes. This is because any attempt to intercept and read the quantum data would disrupt the superposition, alerting the intended recipients to the breach. The revolutionary potential of these technologies could fundamentally transform how we process, compute, and communicate information. It's like opening a new chapter in technological innovation, one that's driven by the unique capabilities of superposition. However, let's not forget that we're still in the early stages of understanding and harnessing superposition. There are many mysteries yet to unravel, many questions yet to answer. But that's what makes this journey so exciting. With each new discovery, we're not just advancing technology, we're reshaping our understanding of the universe. As we unravel the mysteries of quantum superposition, we step closer to a future where the impossible becomes possible.